Okay, so I'm on page 7 of our unit packet, and we're going to be going over 3 properties of logarithms. So the first property that we're going to be going over is called the product property. So how it works, I have log of base b u times v. These are 2 variables. Whenever we're multiplying, if you want to expand this into 2 different logs, then you add log, notice that our bases are the same, log of u plus log of v. So I'm going to do an example here. Log of 2x, so I have 2 times x. If I want to expand this into 2 different logs, this is going to be log 2 plus log x. Now here, I don't have a base value. That's because it's an invisible 10. So my base is going to stay consistent here, invisible 10, invisible 10. All right, let's go to our quotient property. So if I'm dividing here, log of u over v, then I'm going to subtract if I want to expand the 2 logs. So let's say I have log of x over z, then this is going to be the same thing as log x minus log z. Notice that these properties are the exact same as our properties for exponents. So let's quickly review that. If I had x squared times x to the 4th, if I'm multiplying by the same bases, then I'm going to add the exponents, just like I added the log. So this would be x to the 6th. Or if I was dividing, then I subtract with logs. When I had exponents, if I had x squared over x to the 4th, I would subtract my exponent. So 2 minus 4 would give me x to the negative 2, which I know is 1 over x squared. Alright, so then the last rule we went over yesterday is called the product. It's called the power property, my bad. So, whenever we have a log and then an exponent, we bring that down to the front of the log. We call this the power property. That's the whole point of taking the log, so you can bring down your exponent. So the u is hot, you want to bring it down. Alright, so an example of that, if I have log to the 2 to the 5th power, then I bring down my 5 in front and I have 5 log 2. Alright, let's go over these examples. These examples say, expand the logarithm expressions and state which property you are using. You don't have to state the property. Let's just do what we need to do. So, if I'm dividing, my property is the quotient property, so that means I'm going to subtract my logs when I expand. Notice my base of 5 is not going to change. So I'm going to have log of base 5, 3, minus log of base 5, 7. Done. Alright, next example. If I have log of base 3 to the 42. Now here, we don't necessarily have to expand any logs here, but if I'm, let's say, evaluating this expression, then I want to change this to an exponential form. So I'm just going to say that this is equal to x. So I circle my 3, fish, catch the x. So I'm going to have, the 3 is going to become the bigger number. 3 to the x is equal to 42. And I can try and figure out what x is that way. Now, if I have, notice that I'm multiplying the 7 times the x here, and then I'm dividing by y. Whenever we multiply, that's the product property, we're adding the logs. Whenever I divide, I'm subtracting the logs. So this one, I'm going to have log 7 of base 7 with the larger 7. And then because this is 7 times x, I'm going to have 7 plus x. So plus log of base 7 x. The y is on the bottom. So when I divide, I subtract. So that means I'm going to have minus log of base 7 y. Alright, natural log of 40 is equal to x. So if I want to evaluate this, then, now natural log, whenever you have a base, usually the invisible base with logs is 10. The invisible base with natural log is e. So if I'm converting this to an exponent, I would circle the e, catch my x, and I would have e to the x is equal to 40. This, remember, the natural log is an exception. With log, it's an invisible 10. With natural log, it's an invisible e.